This is the video for the very last lesson in this unit. Our learning targets is given a scenario, I can set up a system of inequalities to model it, and I can graph the solution set to a system and determine possible solutions. So let's go ahead and get started. There's a lot of times in businesses or even in life where you're trying to figure out things like, how can I work the fewest number of hours and earn the most money possible? And when you're looking at situations like this, a perfect thing to use is systems of inequalities. So let's go ahead and look at exercise 1. Exercise 1 says John mows yards for his father's landscaping business for $10 per hour. If you have 2 different colors, this might be a good time to use that. So we've got the landscaping business is $10 per hour, and he works at a bakery for $15 per hour. He can work at most 52 hours per week. I'm going to use a different color for this. And he needs to make at least $600 per week to cover his living expenses. So part A says, if John works 14 hours mowing and 30 hours at the bakery, does this satisfy all of the problem's constraints? Constraints are things that are requirements or goals. Or limitations. So his goals and limitations, he can work at most 52 hours per week, and he needs to make at least $600. So the first thing I want to check is if he works 14 hours and 30 hours, is that within his 52-hour per week limit? So 14 plus 30 is 44 hours, which is less than 52, so that's okay. Mowing, he earns $10 an hour. So 10 times 14 would be the money he would make landscaping. And then at the bakery, he earns $15 per hour. So I'm curious if that's going to be enough money for him. So 10 times 14 plus 15 times 30 gives me $590. So unfortunately, this will not work. He's not going to make enough money. Part B says if X is the hours John spends mowing and Y is the hours he spends at the bakery, write a system of inequalities that describes this scenario. So we have 2 constraints. We know that he cannot work more than 52 hours. So if we take the hours that he works at the bakery, the hours he spends mowing plus the hours he works at the bakery, that has to be less than or equal to 52 because he can work at most 52 hours. My second constraint is he needs to make at least $600. Since we're talking about money, this is when we're going to include the amount of money that he earns at each job. He earns $10 per hour landscaping plus $15 per hour at the bakery, and that needs to be greater than or equal to 600 because he needs to make 600 or more. Part C says if John must work a minimum of 10 hours for his father, will he be able to make enough money to cover his living expenses? So the reason, if we look, minimum of 10 hours for his father works in a landscaping company, and that's where he earns the least amount of money. So if I want to know if he'll make enough money, I'm going to say, okay, let's say he works 10 hours. If he needs to work a minimum of 10 hours for his dad, and we want him to make the most money possible, we're going to say, okay, you're going to work the least amount that you can at the lawn mowing company, which means if he has 52 hours to work, 52 minus 10 is 42 hours that he can pick up at the bakery. So now the question is, will that split of hours make him at least $600 a week? So I've got to take $10 per hour times 10 hours plus $15 per hour times 42 hours and see if that is greater than or equal to 600. And it is. That gives him $730. So yes, he can cover his expenses working 10 hours for his dad and the rest of the time at the bakery. Part D says graph the systems of inequalities below with the help of your calculator. Use the space to think about how to graph these lines, indicate your graphing window. So let's go to the calculator and let's go down, to a graph. I'm going to hit delete and choose relation because in my top inequality, y is not by itself. So x plus y is less than or equal to 52. And my whole screen turned blue. So what in the world does this mean? Well, sometimes in a real world situation, we've got to think about what our largest possible x and y values might be. So I'm going to start with my top inequality, but I'm going to graph it as a line. X plus y equals 52. And I'm going to figure out what my x-intercept is and what my y-intercept is, because that'll give me an idea of how far up the x and y axis I have to go. To find an x-intercept, we let y equal 0 and we solve for x. So in this equation here, I'm going to say x plus 0 equals 52, which means x is 52. If he does not work any hours at the bakery, he's going to work all 52 hours at the landscaping company. To find a y-intercept, we just do the opposite. We let x be 0 and we solve for y. So 0 plus y is 52. Same thing. My y-intercept would be 52 here. Okay, so the most number of hours he can work at either place is 52. What this is going to allow me to do is if I go to my calculator and I scroll up here to the top where my y-axis is, I can change that value. Now, I could change it to exactly 52. I'm going to go just a little bit higher. I'm going to say 60. And then down here on my x-axis, I'm going to do the same thing. I'm going to let that go up to 60. And now I get a much better idea of what this inequality looks like. So on my y-axis, I'm going to come up here to 52 and put a spot or a dot for my y-intercept. On my x-intercept, I'm going to come down here and put a 52 and put a point. And then I'm going to connect them with a solid line. And I know I'm going to shade below, but I'm going to save the shading for the end. So that's my first equation. Now, you can go through and trace your graph and go all the way over and find your x-intercept if you want to. This is just a little bit more efficient of a way to do it. For my second inequality, it's 10x plus 15y is greater than or equal to 600. I'm going to graph the line where it equals 600. And I'm going to find my x and y intercepts. So my x-intercept, I'm going to let y be 0. So I'm going to have 10x plus 15 times 0 equals 600. So that means 10x equals 600, and x would be 60. So for my second line, I'm going to go out to 60 on my x-axis, and that's my x-intercept. My y-intercept for my second line, I'm going to let x be 0 and solve for y. So I would have 10 times 0 plus 15y equals 600. So that means 15y is 600. And y would equal 15 goes into 60. I think that's going to be 40. So down here, I'll come to my y-axis. I'm going to put a 40 and I'm going to put a point. And now I can go ahead and connect those two. Ooh, that line was not so good. Let me try that again. There we go. That's better. So now I'll go ahead and hit tab, and I'm going to enter my second inequality. So 10x plus 15y must be greater than or equal to 600. If I hit enter, I can see that my solution is this area right here. So any combination of hours that lies in that area will satisfy the constraints. Part E says, oh, and don't forget to sign your line. Sorry, I forgot about that. So this would be x plus y is less than or equal to 52. And the pink line is this guy right here. So just don't forget to label your lines. John's father needs him to work a lot at the landscaping business. Show the point on the graph that corresponds to the greatest number of hours he can work while still covering his expenses. So hours spent mowing, I want to know the greatest number of hours he can spend. So it's going to have to be in this solution set. So it's furthest to the right. It looks like it's at the intersection point. So I'm going to go ahead and click Menu, Analyze Graph, Intersection, and I'm going to go to one side and click, go to the other side and click, and I get that my intersection is 3616. X is the hours spent mowing. So the most number of hours he can spend is 36 hours at the landscaping company. Algebraically, find the greatest number of hours that John can work for his father and still cover his expenses. So that the greatest number of hours, again, would be this intersection. So I'm going to find the solution to the system of equations. To find the solution, I'm going to use elimination. So I'm going to multiply the top equation by -10. I can add these together. Divide by 5. And I get that y equals 16. That's not the greatest number of hours he can work for his father. That's the landscaping company. So that's X. So then I would do 52 minus 16 equals 36. That's the greatest number of hours. And again, that's how we would find it algebraically. Okay. Exercise 2, for each of the following, write a system of inequalities that models the problem. You do not need to solve it. So let's look at the first one. Dion is putting together a bouquet of roses and daisies. He wants at least one rose and at least 2 more daisies than roses. Roses cost $4 each and daisies cost $2 each. Dion must spend $40 or less on this bouquet. So The first thing I notice that's a constraint is he wants at least 1 rose. So R is the number of roses. So R must be greater than or equal to 1. That means he's got at least 1 rose. The second constraint, at least 2 more daisies than roses. So at least 2 more daisies. So the daisies must be greater than or equal to the roses plus 2. So he wants to have at least 2 more. And then they give me a constraint on the money. Roses are $4 each, so 4R, plus daisies are $2 each, 2D. If he's got to spend 40 or less, it must be less than or equal to 40. So there would be my system of inequalities. Part B, a diet food company is attempting to create a non-carb brownie composed entirely of fat and protein. The brownie must weigh at least 10 grams, but have no more than 100 calories. Fat has 9 calories per gram and protein has 4 calories per gram. If X represents the weight in grams of protein and Y is the weight in grams of fat, write the system. So the brownie must weigh at least 10 grams. So X is the weight of the protein, Y is the weight of the fat, and that needs to be at least, so greater than or equal to 10 grams. Calories is something different. Fat's got 9 calories per gram. So 9, now be careful because this is fat, and Y is the weight in grams of fat. So this would be 9Y plus protein has 4 calories per gram. So that would be 4X, and it can have no more than 100 calories. So it's got to be less than or equal to 100. So there's the system of inequalities. So again, you've got to read carefully. Make sure you put the correct variable with the correct information. Okay, this is our last one. The drama club at a local high school is trying to raise money by putting on a play. They have only 500 seats in the auditorium that they're using and are selling tickets for the seats at $5 per child and $10 per adult. They must sell at least $2,000 worth of tickets. If X is the number of children's tickets and Y is the number of adults, write a system of inequalities. So if they have only 500 seats, then the number of children and adult tickets that they sell must be less than or equal to 500. They can't sell above the number of seats that they have. We also know it's $5 per child's ticket. So 5X plus $10 per adult, 10Y, and they've got to sell at least $2,000, so it must be greater than or equal to 2,000. Part B says sketch the solution set. So I'm going to do the same thing that we did on the previous problem. I'm going to figure out my X and Y intercepts for each of these. So my first equation is X plus Y. I'm going to do equals 500 just to make it easier to find my intercepts. So if X equals 0, we would get 0 plus Y equals 500. So Y would equal 500. So I've got a Y-intercept of 500. Basically, if they sell no children's tickets, they can sell up to 500 adult tickets. And then if Y is 0, I would have X plus 0 equals 500. So X would be 500. So my first line is going to look something like that. My second line, 5X plus 10Y equals 2,000. So I'm going to start by letting X be 0. So 5 times 0 plus 10Y. equals 2,000. So that's 10y equals 2,000 and y equals 200. So my second line is going to have a y-intercept of 200. And then I'm going to do the same thing with this, but I'm going to let y be 0 and figure out the biggest x I can have. So I get 5x equals 2,000. Divide both sides by 5, and we get x equals 400. So my x-intercept is 400. So now let me go ahead. I'm going to open a new graph, and I'm going to graph it as a relation. So I've got x plus y must be less than or equal to 500. Enter. Again, that whole thing ended up getting shaded, but I can see from my graph that my x and y's go up to 600. So I'm going to go ahead and change that to 600 and this to 600. And now I get a better idea of that line. I'll hit tab. I'm going to put my second one in. So 5x plus 10y must be greater than or equal to 2,000. Hopefully it looks like what we've got here, and it does. So when I look at where my solution is any combination of tickets that's in here. We'll have enough seats and we'll make enough money. If the drama club sold 300 tickets to children, what range of adult tickets could they sell and still meet their goals? So if we look, 300 children's tickets is here. So my adult tickets can lie anywhere from between here and here. So I'm going to start, I think we should probably trace this graph. So go to menu, trace, graph trace. And I'm going to start by typing in 300 for X. So it looks like the maximum, the top value is at 200. And the minimum value, if I hit my down arrow, I see it's at 50. Ooh, my lines were actually pretty close. So it looks like they could sell anywhere from 50 up to 300. Nope, just kidding. 200. I was going to say 200 adult tickets. And again, that's just figuring out if we sell 300 children's tickets, what are our possible options? Our adult tickets could be anywhere in between there. Is it possible for the students to sell exactly 500 tickets and make exactly $2,000? Well, this line, this purple line, is all the ways they can sell exactly 500 tickets. This kind of burgundy line is exactly the number of ways that they can make $2,000. And within this area, they do not intersect. So no, it's not possible. Because within this domain, the lines do not intersect. Now, it's important to note, let me just write this. That does not mean that there aren't possible combinations where there's less than 500 tickets and they make more than $2,000. Any point in here is a possible number of tickets they could sell where they make more than $2,000. The key is there's no workable combination where they sell exactly 500 tickets and make exactly $2,000. There's a lot of places where they sell fewer than 500 and make more than 2,000, which is what our requirements were. What I'd like you to do to finish this up is go ahead and pause the video and try the next two problems, all of the parts, and then hit play to check your work. Here's the first solution. So if you need to pause this to take a look at this, you can. I'm going to scroll down to E now. And then the solution to the next problem looks like this. And that was all that you had to do. Okay, that's it for Unit 5. There's some practice on word problems that you can work on and a review packet as well. And don't hesitate to come in if you've got some questions. Thanks so much.